Hello. Today in lesson 36, we're going to talk about using parallel and perpendicular lines. Your warm-up going into this, starting off with your vocabulary. If you know the slope of a line and a point on the line, you can use the blank formula to write the equation of the line. So anytime you would know a point and a slope, we can simply call that the point slope form of a line. And then if we want to find the slope of the line that crosses through 1, 4 and 5, 9, for that we were going to use our slope formula, which is m is equal to y2 minus y1 over x2 minus x1. Remember, for that, whatever our y2 is, that x value has to go with that. So for example, if I pick 9 to be my y2, I would have minus 4. But that means I have to start with 5 because that's the x value that goes with 9. So 9 minus 4 is 5, and 5 minus 1 is 4. So that slope would be 5/4 for us there. And then lastly, number 3, write the equation 3x minus 7y equals 28 in slope-intercept form. So let me just rewrite this real quick. Our first step, if we want to get it in slope-intercept form, remember that that would be y equals mx plus b. So we're getting y all by itself. So our first step is going to be to subtract 3x from both sides. Now, since we can't do 28 minus 3x, since 3x has a variable, we would just rewrite those. So we'll have negative 7y equals, now I'm going to write that 3x, that negative 3x first, just so that it lines up with our slope-intercept form, and then it'll be plus 28. And then last, we will divide by negative 7, everything by negative 7. So we get y equals, negative divided by a negative is a positive, so 3/7 x, and then 28 divided by negative 7 would be negative 4. So there's our equation of our line in slope-intercept form. All right, so if we are talking about parallel and perpendicular slopes, the important thing to remember about parallel lines is that they have exactly the same slope. So if we looked at L1 and L2 here, we can see that they're parallel, but if we have to show that those two are parallel, then we have to show that their slopes are the same. So the way that we can do that is we can use our slope formula that we just used in our warm-up, using those points that they give us. So there's one line. So I'm going to do negative 2 minus 0 over negative 1 minus negative 3. So I get negative 2 over negative 1 minus negative 3. That turns into a plus. So we get a slope of negative 1. Now the second line over here, I'm going to use those points. So 1 minus negative 2 over 0 minus 3. We get a positive 3 over negative 3, which is negative 1. Because those two have the same slope, that shows that those two lines are parallel. Now, for perpendicular, we would want to show that those slopes are opposite reciprocal to one another. So what that means is if I had a slope of 1/2, opposite reciprocal, first off, opposite, it's talking about the opposite sign, so it would be negative, and then the reciprocal, meaning that we flip that numerator and denominator. So, shouldn't write equals, but these two slopes would be perpendicular to one another. So we can take a look at what they give us. I'll use that blue line first. Negative 3 minus 1 over 1 minus negative 1. So we get negative 4 over 2, which equals negative 2. Oh, I might have just accidentally used the right slopes there. And then we have negative 1 minus negative 3 over 2 minus negative 2. For that top part, we get 2 over 4. If we reduce that, we get positive 1/2. So same example I just used, which is kind of a coincidence, but they're opposite reciprocal to one another. So we could write that negative 2 as a negative 2 over 1, just to show even more that that would be a reciprocal like I did up there. So those would be perpendicular to one another. All right, if we want to find the equation parallel and perpendicular to this one that crosses through a specific point. So for parallel, we know that those need to have the same slope. So this has a slope of 3 since that's in slope-intercept form. Now I'm going to use point-slope form so that I know that it can go through that specific point that they give me. So I'm going to say y minus, our y1 would be 3, equals 3, which is that slope right there, times x minus 2. So again, this is for parallel. Now we just have to simplify. So this is equal to 3x minus 6, y minus 3, add 3 to both sides. So our final answer for our first piece is y equals 3x minus 3. All right, now for perpendicular, I'm going to do the same type of process, but we know from our last example that the slope has to be opposite reciprocal. So we have to say what's opposite reciprocal to 3. So that slope is going to be negative 1/3. Now we're crossing through that same point, so I'm using the same point-slope form, but the slope will be a little bit different. So that's going to look like y minus 3 is equal to negative 1/3, and then x minus 2. Again, distribute. So we get negative 1/3 x plus 2/3. That's y minus 3 is equal to all of that. Add 3 to both sides. I could either think of this as 9 over 3 and add 2 to get 11 over 3, or actually I think I will do that. But that would simply reduce to 3 2/3 if I simplified that. So there is our perpendicular line. All right, I will leave this one for you guys to do. So make sure you pause the video and take a look at this. That negative 0.5, you could always rewrite that as negative 1/2 for your slope. So there's the little pointer there. And moving on. All right, given two equations, determine if they are perpendicular or parallel. So the easiest way to figure that out would be to get them in slope-intercept form. That's generally our nicest equation for anything. When we're trying to figure out anything, it just tells us the most information. So if I'm going through and solving this, plus 27, divide by 3, divide by 3, divide by 3, y equals negative 5/3 x, and then that simplified down would be plus 9. Now if I take a look at the other one, I will subtract 15x. So I get 9y equals negative 15 x minus 72 and divide by 9. Y equals, that will be, we can simplify that down by taking out a 3 to negative 5 thirds x, and then that would be minus 8. So since these two things have the same slope, those will be parallel to one another. All right, second piece, looking at information a little bit differently. The first one, we were given two equations. In this problem, we are given information inside of a table. Now they tell us that the points A, B, and C are collinear, meaning that these three over here will make up a line, where D, E, and F over here will make up a line. We want to compare those equations and figure out if they are perpendicular or parallel. So I'm just going to pick two. I'm going to pick A and C. So the first thing I'm going to do is find the slope. So that's going to be 8 minus 0.5 over 4 minus 1. Then I'll do the same thing with our other side. Negative 0.9 minus 0.7 over 6 minus 2. Now I really only have to look at the slopes if I'm trying to determine if they're parallel or perpendicular. So that'd be 7.5 over 3. And this would be 0.2 over 4. So it doesn't look like these are parallel or perpendicular. 7.3 over 5 would be greater than 1. 0.2 over 4 would be a very small number. However, since they're both positive, these would just be neither, looking at their slopes. All right. And then finding vertical and horizontal lines. Vertical and horizontal lines would obviously be perpendicular to one another, but if we're going to find the equation of a line perpendicular to the graph y equals 2, that passes through the point 4, negative 1. So y equals 2 is a horizontal line that would be at the point y equals 2. Now, if I'm trying to figure out the line that's perpendicular that passes through that specific point, I just have to look at the x value. So our x value is at 4. If I drew a line that went through 4, it'll be a vertical line. So really, we just have to look at one of those points depending on what they give us. Again, I'll have you try this one out. So pause the video, write that information down. And then our last one, let's see if I have a little bit of time. So I'm trying to figure out that this is a right triangle. So that would mean that this point right here, or that angle, would be a right angle, because the hypotenuse wouldn't be a right angle. So I'm going to find the slopes of those hopefully pretty quickly. So I'm going to do 6 minus 2. This is the points B and A. And 1 minus 5, so I get 4 over negative 4, which equals negative 1. That's one slope, and then I'm going to do C and A. So I'll do 5 minus 2 over 8 minus 5. So I get 3 over 3, which is positive 1. So since that's negative 1 and that's positive 1, those two would be perpendicular to one another. I hope this helps out for some of you, whether you're gone or just need the extra practice. I hope you have a great day, and thank you.